professors, research scholars, students, and industrial experts in the field of computing and communication to a common forum. The primary goal of the conference is to promote the exchange of innovative scientific information between researchers, developers, engineers, students, and practitioners. Another goal is to promote the transformation of fundamental research into institutional and industrialized research and to convert applied exploration into real-time application. Overall, the conference will provide the researchers and attendees with prospects for national and international collaboration and networking among universities and institutes from India and abroad for promoting research. ICDAM 2022 is organized by the KARKONOSZE University of Applied Poland, Europe on 25th to 26th June 2022, along with the academic partner University of Craiova, Romania, Warsaw University of Life Sciences, Poland, and University Tun Hussein in Malaysia. All the accepted papers after double-blinded peer review will be published in Springer's lecture notes on networks and systems, indexing, SCOPUS, INSPEC, EL Compendex, WOS, approved and extended selected papers will be published in the special issues of SCI, SCOPUS, WOS, DBLP, ACM Index Journals.
About the KARKONOSZE University of Applied Sciences, JELENIA GORA, Poland, Europe. The KARKONOSZE University of Applied Sciences is a state higher education institution in JELENIA GORA, Poland. The university is the only autonomous higher education institution in the KARKONOSZE region. Therefore, it aspires to fulfill its cultural obligations, offering a broad range of courses in the fields of social sciences and humanities, as well as natural sciences and technology. The KARKONOSZE University of Applied Sciences in JELENIA GORA was established on 1st July 1998. The first name of the institution was Collegium KARKONOSZE. On 4th December 2010, the official name of institution in Polish had changed into Karkonoska Pantasova Szkola Wyż w Jelenia Górze, with official translation into English as KARKONOSZE College in Jelenia Gora. Later, the official translation had been changed into the KARKONOSZE State University of Applied Sciences. In 2011, the renovation of a modern gym was completed, and in 2012, a swimming pool with health treatment facilities was opened. On 2nd May 2022, the official name of the institution in Polish has changed into Karkonoska Akademia Nauk Stoswing, KANS, with official translation, the KARKONOSZE University of Applied Sciences in Jelenia Gora. Now, about our academic partner, Universal Innovator. The Universal Innovators is a private autonomous body promoting research-based innovative activities all over the globe for overall growth of human and environment. The Universal Innovators aims to do non-profit collaborative research in the field of engineering, applied sciences, management, and other domains. The Universal Innovator aims to be the leading independent academic and professional body working in collaboration with different academicians, faculties, students, researchers, industry experts, private bodies, government bodies, and educational institutes. The mission of Universal Innovator is to cultivate and carry out research in high-tech, productive, and cost-efficient methodologies. Universal Innovator is an Indian research lab to promote research and development in India via conferences, FDPs, workshops, seminars, summer and winter schools, journals, research journals, patents, paper publication, book publications, and collaborated national and international projects. For the first address, I would like to welcome Dr. Beata Jelska, Professor of the KARKONOSZE University of Applied Sciences, who is a Vice Rector of the University and Patron at ICDAM 2022.
Hello, can you hear me?
Yes, ma'am.
It's very nice to see you. I have the great privilege and great honor to welcome you. It's very nice to see you. And I know that some of you will come to Poland and we will see let's say, face to face. I'd like to introduce Professor Zaprutsky, who is next to me. And I know that Marek Runiewicz also is somewhere next to me, and he is taking part in our conference. So we are very, let's say, delighted to take part in this conference, and we'd like to say that it is very pleasant to see you, and I hope you will enjoy the lectures, and I hope we'll continue our, let's say, mutual cooperation. All the best, and see you in Poland, and let's continue our cooperation.
Greetings from Silesia.
Yes.
The west part of Poland.
Thank you very much.
Thank you, ma'am. Thank you, sir. Now, for brief presentation of the university by Marek Runiewicz, who is a chair local committee ICDM 2022, I would like to welcome you, sir.
Okay, now you can hear me. I think I said good morning, and good evening, good afternoon, everybody. Let me share the screen. So our university, as it was previously said, it's in the process of change its name in Polish, but in English it's still the same, the KARKONOSZE University of Applied Sciences. That's our website, which is in English. And as you can see, we cooperate during Erasmus welcoming days. We have staff teaching, training weeks. And I would like to show you our map, where you can see all our contacts. Here we have the US, China, Germany, Czech Republic, Latvia, Turkey, and other countries. And here is the list of our Erasmus Plus partner institutions. And we would like to cooperate with many more. And our partners which are not in the EU, as I said previously, Tyler Junior College in the US, Changzhou Technical College in China, and in Ukraine we have two partners, Lviv Physical Education University and Vinnytsia State Pedagogical University. And we are also cooperating with Syrian Arab Republic, and we are open to new partners. We are members of the European Union. We participate in many projects. And if you have any questions, you can contact me or Professor Zaprutsky. These are our mails, foreign@cans.pl and our personal emails around here. Thank you very much.
Thank you, sir. That was a great insight about the university. Now over to share.
Now, I would like to welcome Dr. Ashish Khanna, convener, ICDM 2022.
Sir, you are muted. Ashish Khanna, sir.
So this is new normal for all of us. And good afternoon to all. On behalf of ICDM 2022, I, Dr. Ashish Khanna, the convener of the conference, welcomes you all to the third version of the Indo-European Conference, that is the International Conference on Data Analytics and Management. ICDM 2022 is organized jointly by the KARKONOSZE University of Applied Sciences, Poland, in collaboration with University of Craiova, Romania, Warsaw University of Life Sciences, Poland, University Tun Hussein on Malaysia, and Universal Innovator Lab. ICDM 2022 has proudly received 370 research papers from around 15 countries. And after the rigorous and standard review process, only 71 papers have been accepted and registered with the acceptance ratio of only 19%. This conference is unique in many ways. It is a third version of the Indo-European Conference. All the papers will be published in reputed Springer series, that is the LNNS Scopus Index series of Springer, and the best extended papers will be sent to SCI and other reputed journals like Sustainable Energy Technologies and Assessments of Elsewhere, which is an SCI indexed journals with an impact factor of 35.35, CMES Computer Modeling in Engineering and Sciences of Tech Science Press, and SCI journals with an impact factor of 1.59, Intelligent Decision Technologies of iOS Press, which is indexed in Scopus and Web of Science, Frontier in Computational Neuroscience, an SCI journal with impact factor of 2.38, IET Communication, an SCI journal with an impact factor of 1.19, CMC, that is Computer Material and Continua of Tech Science Press, an SCI journal with an impact factor of 3.77. So this is the third version of the conference, which is going to be successfully organized through online mode due to various reasons. ICDM 2022 is the third version of the International Conference on Data Analytics and Management, and all the accepted papers will be published in the Springer series, that is lecture notes in networks and systems. The theme of the conference is data analytics and management. The theme of the conference is very apt in the current scenario where huge amount of data is produced on daily basis. We need more events like ICDM to accumulate quality research work on the same. After the brief description of the conference, I would like to welcome our dignitaries, patron of ICDM 2022, Dr. Beata Telazka, Professor of the KARKONOSZE University of Applied Sciences, Vice Rector of the University, and Professor Dr. Violeta. Our conference chair, Professor Dr. Polkowski from the KARKONOSZE University of Applied Sciences, Poland, and our keynote speakers, Professor Amir H. Genwani from University of Technology, Australia, Professor A.K. Singh from NIT Kurukshetra, India, and Dr. Vipul Kumar Mishra from Bennett University, Greater Noida. Also, my sincere gratitude to our journal chairs, Professor Dr. Janus from Polish Academy of Sciences and Professor Oscar Castillo from Mexico. Our honorary chairs, Professor Vaclav Snessel from Czech Republic and Dr. Abol Ella Hasnan from Egypt. I would also like to thank our conference chair, TPC chairs, technical programs co-chairs, publication chairs, conveners, co-conveners, publicity chairs for giving their valuable support of the conference. I would also like to give my special thanks to Aninda Bose from Springer, Professor Polkowski from Poland. Without their active support, this conference would not have been possible. I would also like to acknowledge our reviewers for their active support, guidance, and reviewing of the paper for the conference. Our students from the organizing and co-organizing institutes have played a key role in the organization of the conference. At last, I would like to give special appreciation to the participants who have come from various parts of the world to present and share their research with us in the coming days. Thank you so much. Over to you.
Thank you so much, sir. Thank you so much, sir, for your addressing.
Now I would like to welcome Professor Dr. Zdzislaw Polkowski, who is a professor of the KARKONOSZE University of Applied Sciences and conference chair at ICDM 2022. Please, sir.
Namaskar. I am pleased to announce that I can represent the KARKONOSZE University of Applied Sciences during International Conference on Data Analytics and Management. Universities from India, Poland, Romania, and Malaysia are trying to create a platform for professionalist academicians, research scholars, and students to share and express their views on new trends in data analytics and management. I believe that this conference will provide a very good platform with knowledge creation, skills, and development of innovative orientation among all who are and will be the part of this conference. Organization of a conference is a big effort of many months by many individuals. I am glad that publication partner Springer will help to publish the highest quality scientific articles. Experts of reputed national and international institutes have agreed to deliver keynote addresses, invited talks, and chair the technical session during the conference. Such activities mean that together we are building one large international scientific family. Also, I would like to thank our scientific partners from India for the invitation to be part of this conference. I would like to express my gratitude to keynote speakers and authors from many countries. I wish the conference all the success. Good luck. Thank you very much.
Thank you so much, sir, for your kind words. Now, an address by Professor Dr. Piotr Pierzak, who is from Warsaw University of Life Sciences, Poland, and an academic partner of ICDAM 2022. Please, sir.
Hello, everybody. My name is Piotr Pietrzak. I'm from Warsaw University of Life Sciences. I prepared a short presentation for you, but I can share my screen. Could you give me an access? Okay, thank you very much. Okay, so I want to show you the most important information about our university, Warsaw University of Life Sciences and Management Institute. So the Warsaw University of Life Sciences, like it was mentioned, is the oldest agricultural university in Poland and the fourth of this type in Europe. Its origins date back to 1816 and are related to the establishment of the Agronomic Institute in Marymont. The advocates of its foundation were Stanisław Staszic and Stanisław Potocki, and its first director was Jerzy Benjamin Flat, one of the best experts in economic relations in the United Kingdom of Poland. So nowadays, Warsaw University of Life Sciences is one of the biggest higher education institutions in Poland. The university offers 40 fields of study, including 8 thought in English, from natural science and technology to veterinary medicine, social and economic studies, and there are nearly 18,000 students in full-time, part-time, doctoral, and postgraduate study courses, as well as under international student exchange. This year, Warsaw University of Life Sciences won in 5 categories in the Perspective 2022 ranking. So we won in such categories as landscape architecture, didactics, horticulture, veterinary medicine, agriculture, and forestry. And we were placed also in different both national and global rankings. And in our structure, we have 14 faculties and 16 institutes. And I want you to tell something about my institute, so our Management Institute. And this institute was established in 2019, and the institute in its assumptions conducts research as well as disseminates knowledge in the field of management science, quality, and in particular knowledge management, digital management, or social corporate responsibility or about university social responsibility. And the institute attaches great importance to cooperation with domestic and in particular foreign universities and other research entities. And the institute takes care of the high level of knowledge, skills, and competences of its staff. Here you have the picture of director of our institute, Professor Joanna Paliszkiewicz. We have 15 members in our institute, and here you have our books. They were printed in Taylor and Francis. So we have, for example, management in the era of big data or trust, organization, and digital economy. Thank you very much for attention and for the chance to cooperate together in this project. Thank you very much.
Thank you, sir, for your addressing. Now over to Shreya.
Now, for vote of thanks, I would like to invite Dr. Deepak Gupta, Joint Convener, ICDAM 2022.
Thank you, Shreya. I would like to welcome all the participants and good afternoon, good evening, and good morning to all the participants of this conference from 15 countries. I deem it a great honor and privilege to propose the vote of thanks. First and foremost, I would like to express my heartfelt thanks to Vice Rector, Dr. Beata Teleska, Dr. Mark Ranovich, and Dr. Zdzisław Pulowski of KARKONOSZE University of Applied Sciences, Poland. I would like to thank Dr. Piotr Petjak from Warsaw University of Life Sciences, Poland, for their valuable time and presence in this inaugural ceremony. We are grateful to our general chairs, Professor Oscar Castillo from Tijuana Institute of Technology, Mexico, Professor Janesus from Polish Academy of Sciences, Poland, for their kind support during the execution of this international conference. I would like to give my sincere thanks to Honorable Rector of KARKONOSZE University of Applied Sciences, Poland, Professor Jonita Palczewska, for his leadership, our constant support of motivation, and creating an ecosystem for smoother conduction of Third International Conference on Data Analytics and Management. My sincere thanks goes to all the faculties and staff of the organizing universities, that is KARKONOSZE University of Applied Sciences, Poland, University of Krailowa, Romania, Warsaw University of Life Sciences, Poland, and Tun Hussein University, Malaysia. Special thanks to Mr. Mulchan Sharma, co-convener, ICDAM 2022. Without him, the conference would not be possible. At last, I would like to thank our sponsors, student volunteers, reviewers, special session organizers, participants, keynote speakers, and publishing partner for their constant support in organizing the conference in virtual mode. Now, I am happy to announce that this conference is a grand success. It is an honor for me to thank all the participants in ICDAM 2022. Thank you so much.
Thank you, sir.
Our first keynote session presenter is joining in a while. Please, we have to wait for a while.
So while our keynote speaker is joining in a moment, so as we all know that this is a new normal, and that the we all are connected on online mode, and means we can face various problems while joining onto the platforms. So we all know that the theme of the conference is data analytics and management, and which is nowadays very in, and doing research on this particular topic is really very interesting, because huge amount of data is coming out of from various parts. We go on in any particular field, um, the the data is getting generated, and we need the some means various techniques, more efficient techniques, so that we can have predictions on the basis of that. Let us on the predictions, the valuable predictions, which will help in various multidisciplinary research areas. We go for any particular technique, technology, or computer science research area, whether it is IoT, cloud computing. So everything is connected nowadays, and means we are not basically working on in a particular and in a particular field. We have to be we should have the knowledge of all the technologies which are working in collaboration with each other. So for example, if we take one example, that the data is getting produced on the in the agriculture on the agriculture land, there are various sensors which are accumulating the data. That is the we can say that the telemetry is getting used to calculate the data, to not to calculate, to take the data. For example, it could be the moisture of the soil or the air, and this particular data is transferred to either to the edge onto the edge computing area, or to the cloud, where this data is basically applied on various data analytic tools, and we get the valuable uh, output on the basis of that data, through which we can basically take decision that whether how much amount of watering has to be given to the agricultural land. So this is one very simple example. Maybe you all are aware of also about it, but we all are we can see that how data analytics is playing the role. If we go into the more crucial part, if we look it into more crucially, for example, if we need more better data analytic techniques, for example, if the rain forecast is there and the rain is about to come, so we need not have to waste our water in watering the plant, because the rain is about to come. We can also have the kind of knowledge. If we go into more detail, then with the previous meteorological data, we can calculate the how much amount of water is going to come into the particular field, and we can adjust the amount of water has to be released in the into the, and this all is an automated process. So we can see that how data analytics is actually helping us in many ways, so that the process becomes automated, and how this whole process is going on. You now, for example, I was just talking about edge computing and cloud computing. What is the difference is that nowadays everything we have to send it on the cloud. So clouds, maybe clouds can be there is a means we can say when the data is, because clouds are not placed very near to the data where the data is getting originated. The clouds are placed into the onto the areas where maybe electricity is cheap. It could be very far from the from that particular area where the data is getting generated. So the edge computing is coming. Edge computing is where on the edges we are placing limited capacity data data calculating devices, which can actually reduce the latency, which can also reduce the power consumption time, so that the output we can get, it makes decision faster. So although this is part of networks, and you must have seen on the website also that the theme of this particular year is networks related to data analytics. So we can see that how closely all the fields are connected, and the way we are basically doing. Now let us take one more example. For example, let us move into more into the, for example, if I take the example of IoT, that is Internet of Things. In the Internet of Things, if I move into Internet of Medical Things, for example, a patient is there, and we have to monitor that particular patient regularly. We have to monitor that patient regularly. In that case, monitor the continuous data which is coming from the patient, and that patient is equipped with multiple sensors. Okay, and if, for example, we are monitoring 100 patients, at all the times we not need all the patients need any the one-to-one assistance of any particular doctor, but doctor, by while having a digital device, can monitor the data of that particular patient automatically with the help of data analytic tools, which action has to be taken. So this is another example where we can see that where data analytics is going to play its role. So we can see that the technology is very fastly moving, and a lot of huge amount of data is getting produced. So we have to see that how the research papers are getting published. Let us move into the quality of the research papers, for example. So we all understand that the research papers have to be published in quality research, either conferences. For example, short papers can be published in conferences, long papers or the complete papers can be sent to the quality journals. It could be SCI journal, it could be Scopus journals, it could be your Web of Science journals, or and those journals are basically are of multiple publishing units like Springer, IEEE, ACM, elsewhere, and so we are actually facing, as far as the research world is facing, because all the authors which are listening to us, the managing a particular international conference is not at all a very easy task, because huge amount of information or the lot of research papers, like just see that the 19% is the acceptance ratio. So we have received around 400 papers. For 400 papers, around 2 to 3 reviews have to be there. We cannot take more than we cannot a particular reviewer cannot review 5 to 10 research papers, more than 5 to 10 research papers. So just see the rigorous process through which this the conference organizers or the universities which are organizing these kinds of conferences are facing. So I would also like to request to all the authors, what is actually peer review? We all say that the papers are double blind peer reviewed, for example. But most of the authors are not able to understand that what actually the peer review is basically. So peer review is something where our peer who is also working in that particular field can be sent, that our research work could be sent to that particular to that researcher, which will review that particular paper without knowing that this paper has been written by you. So this is the basically a distributed process, the fantastic process of reviewing the research work is going on from ages, and we are improving the process. And nowadays the plagiarism is one of the very big issues, because the Springer or elsewhere or many universities are actually facing this problem, because what we have actually is, we are having the tools of uh, the authenticate or Turnitin. So these tools are actually just telling us the plagiarism, that the text which is there, it could be adjusted on the basis of 4 continuous words or 5 continuous words. But nowadays author is becoming more and more smarter. He or she is not putting his mind, some of them, are not putting his mind into quality research work. They are actually copying the data. And I would like to request to all of you that kindly not follow these practices. This is very unethical. Once caught, you could be banned from that particular journal. You could be your reputation will be very down in the coming time. And remember this thing, maybe you are doing your PhD or your MTech. Once that paper, you may get the acceptance, and the after passing through the various stages, although it is a very complex stage. First the plagiarism is checked, multiple reviewers are looking into it, and the review comments are monitored by the journal chair or the convener or the of the conference chair of the conference. And then but mistakes can happen on any particular platform. So in case, even if any particular author is happy that his research paper is getting accepted, the plagiarized research paper is getting accepted, remember this thing, huge number of authors are going to read your paper. They are going to download, because multiple eyes are watching your work in the coming time. So once downloaded and they caught your paper, that this particular paper is matching with any other paper or something like that, they can report it directly to the ethical committee of the publishing house. So their paper could be retracted, and they could be banned from the research community. So plagiarism is a very big crime in the research world. I would like to tell you that we all should not follow these practices. So there are multiple areas on which we can speak upon. And maybe it is plagiarism. Plagiarism is part of the ethical issues which the research world is facing nowadays. So means if we go into the ethics part has a larger perspective. Multiple unethical things are happening in this research world. So let us forward about these things, because this is another critical area. So if we say that the research paper has to be published, means if you have a short paper, then you can publish your research work in the conference, because preparing a research paper, a complete research paper is a very time consuming task. Let me tell you one of my experience. Although I have discussed this on some of the platforms, maybe if you have heard me, then I'm repeating the same. But when I was doing my PhD, I was working on the MANETs, that is a mobile ad hoc networks, and at that time, I was I basically coined a term, that is the group mutual exclusion, and I proposed a new problem into the MANETs area, which is the local group mutual exclusion problem. Just telling you that the terminology which you can check upon. I'm not teaching you the MANETs or the LGME, just telling you that how you can publish your research works more safely, because this is a cat and mouse game. The person who is actually publishing his in a time bound manner, that is his research works, because this is a quite possibility that if some idea is coming to your mind, that idea can simultaneously come to the other researchers' mind also, because as far as the peer researchers are there, your research area could be an area in which lot of researchers are working from around the globe. So I was just telling you that I was working on a problem, and when I was working, because once you are doing your PhD, you are more interested in completing your research works, because so once I coined that term, that is not, I not published that term earlier. That terminology, that was the first terminology into the entire wireless communication. But as I prepared my research work, I coined another terminology, I parallelly I started working on another research work. So in the meantime, my guide sent me a paper that is quite close to my research work into one of the sub area of the wireless technology, that is the WANETs. So now although my research was still unique, but its quality got down, as far not quality, its visibility basically, because it could be first in the wireless. Now I have to compare it with the previous work. So what is the way out? The way out is once you have prepared or you have coined a research works and with after doing the rigorous checking that yes, and rigorous check that yes, this is the unique one, and you can publish that research work, that the partial research work you can publish in any particular conference. Or there are multiple ways also to save your research work. You can save it on the archive, you can save it on you can archive your research work. Springer is providing, elsewhere is providing in various formats. They are providing where you can save your research work. Although that research work becomes part of repository, you need not have to worry about it, because once the complete paper is prepared, if you will check it on the Turnitin, it will be part of archive. But generally the publishers are not looking into that thing, so they ignore that book because that is your work only, that is placed. So once it is archived, your research work is archived, it is because that is a timestamp of that time where you have published it. So it will give you more freedom to work on, because once it is archived, it could be checked by the other researchers, other peer researchers. They can check upon, yes, this work already has been prepared by someone and just waiting for to get published. So these are certain areas, these are certain loopholes which you can look upon, which can be used to fasten up your research work, to get more recognition out of your research work. So there is one misconception among all the authors, is that for example, if we take the ICDAM, because on these platforms, it is also necessary for all of us to remove certain myths related to the research work, to the capacity or to the organizers which are organizing the conferences. Remember this thing very, very clearly, that the conferences are the research validators. They are not the publishers. So even if your paper has been accepted, although you could be, I'm not making you worry about this thing, I will come on to the other part also, because the important part is that okay, I think Professor Amir has come. So just I would like to conclude with this my talk, that my small talk, my just small discussion, that these are conferences are the research validators rather than we are not publishers. We have to send it to the publishing units where that paper is again checked onto the basis of plagiarism and on certain parameters. But yes, the value of the conference is judged by that, yes, your 100% papers, past 100% papers are getting published. So that increases the value or the credibility of the research conference. Thank you so much. Over to you, Satyam.
Yes, sir. Just a second. There was a network issue at my side, so sorry for that. Now, I would like to call Professor Amir Kandomi for the keynote talk on the topic Evolutionary Data Analytics and Optimization. Amir Kandomi is a professor of data science and an ARCDECRA fellow at Faculty of Engineering, Information Technology, University of Technology, Sydney. Prior to joining UTS, Professor Kandomi was an assistant professor at Stevens Institute of Technology, USA, and a distinguished research fellow at Beacon Center, Michigan State University, USA. Professor Kandomi has published over 300 journal papers and 12 books, which collectively have citation of 30,000 plus and an H-index of 79. He has been named as one of the most influential scientific minds and highly cited researcher for 5 consecutive years from 2017 to 2021. He also ranked 17th in GP bibliography among more than 12,000 researchers. He has received multiple prestigious awards for his research excellence and impact, such as 2022 Walter L. Huber Prize, which is known as the highest level of mid-career research award in all areas of civil engineering. He has served as associate editor, guest editor in several prestigious journals such as Associate Editor of IEEE TBD, Transaction on Big Data, and IEEE IoTJ, Internet of Things Journal. Professor Kandumi is active in delivering keynotes and invited talks, and his research interests include global optimization and big data analytics using machine learning and evolutionary computations in particular. If anyone have any questions, they can write in the chat box, and those questions will be addressed at the last. Please, sir, now the stage is yours.
Hello, everyone, and thank you so much for the invitation, especially Professor Gupta for contacting me and inviting me to this event. It was a short call, but I'm happy I could join you for this conference. And also, I would like to excuse, since I had some internet connection problem. I had to change my place in order to connect to the internet. Anyway, this is the problem of connecting during weekend and from home, and I hope you excuse me. Anyway, so the topic of my presentation, actually, it follows the era of data analytics, machine learning, and AI, and it is about evolutionary intelligence for data analytics and optimization. So before going, okay, let me see if okay. Before moving to the technical content, I would like to pay respect to some of the big contributors into the topic of evolution. So the first, we can go back to 13th century, and where evolutionary philosophy was discussed by Jalaluddin Rumi, also known as Maulana. And in one of his poems, he mentioned, for example, I died as mineral and became plant. I died as plant and rose to animal. I died as animal and I was a man. And he was believing evolution in some sort of Darwinian natural selection. But of course, the theory of evolution first introduced by Charles Darwin in his well-known book, On the Origin of Species in 1859. And when we talk about machine learning and evolution, of course, we can go back to Alan Turing, who discussed evolutionary research and learning in one of his papers, and he mentioned there is a genetic or evolutionary search by which a combination of genes is looked for, the criterion being the survival values. So the outline of this presentation has two main parts, as you may already got it from the title. So the first part is how evolutionary intelligence can do data analytics. So there are so many topics, but here I specifically talk about one pure evolutionary intelligence techniques called genetic programming. I will have some introduction, then we'll discuss some advantages and enhancement and how it can be used for big data. And in the second part, I will discuss how evolutionary intelligence can do optimization. Some of the techniques, application, and heuristics will be briefly presented. So first, evolutionary computation or evolutionary intelligence for data analytics. So first, machine learning and natural computation has some overlaps, and one of the topics is evolutionary computation. So we have a very recent survey published at ACM Computing Survey, and we discussed evolutionary machine learning in detail. So if you are interested, I refer you to this paper. But generally, if we want to classify data analytics tools, we have two different classes. First, statistics-based methods such as regression analysis, or AI-based methods such as artificial neural network, fuzzy logics, support vector machines, and also genetic programming, which is the topic of this presentation. So first, what is genetic programming? So simply, I will describe it as when a software with evolution as the programmer. So you can see it has a very, very wide definition, yes? So it can be applied to anything, even a programmer is the evolution. And actually it can be applied in so many different problems. It's proposed by John Koza at Stanford University in 80s. And in one of his books, Professor Koza listed 80-something different applications of genetic programming. But of course, the main applications of genetic programming, and that's what people knows genetic programming for, is data analytics and some sort of optimization and machine learning. So, and that's what we are going to discuss during this presentation. So first, what is how genetic programming works? So genetic programming following the Darwinian natural selection and tries to find relationships between inputs and outputs. So like any other evolutionary algorithm, it has some iteration which called generation in evolutionary topic. And in each generation, it applies different evolutionary operators such as selection, crossover, and mutation. And actually, inspiring from tree of life, it also has a tree-based structure. You can see it can have a mathematical operator in each node, or variable or constant value, or you can define other operators or logical operators, etc. And now crossover can happen between two trees, and new offspring can be created from those parents, and mutation also can happen in so many different ways, such as randomly changing a node. But why genetic programming? Why distinguish these techniques from other techniques in the literature? So the first and the most important features, or to me the most exciting features regarding genetic programming, is it can find the structure via evolution. So if I want to explain it more, in other machine learning techniques or other data analytics techniques, we usually have the structure. The structure is defined, and we only find some constant value or some special parameters in the system. And then this would be our model. For example, in neural network, we have a network structure, and we try to find the weights of those connections, or in some special cases, maybe find the function of those layers. But the structure pretty much defined. But in genetic programming, we don't have any predefined structure. So we try to find a structure through evolution. So it seems completely random structure. It started, and through the iteration, we try to find the best structure for our model, which is very interesting. Actually, one of the well-known examples of GP application is finding the structure of these communication antennas. This actually is designed by genetic programming and outperformed several designs of engineers at NASA. So it simply tries to find the structures, and it can outperform the ones done based on engineering concepts, for example, in this case. Another features of genetic programming is simplicity and explainability. So since we start from scratch, we don't have any assumption for the model. Genetic programming try to build this structure to evolution. It's usually very simple. It usually don't over complex, or in some ways we can control the complexity. So one of the good examples is one of the genetic programming based algorithm actually designed by Kelly et al. In 2017. They tried to apply this genetic programming for Atari game playing. They applied to 50 different game playing and compared with several state-of-the-art, including deep learning. And they found that overall genetic programming can outperform all of these complex models with very, very simple structures. For example, this graph structure you can see here, this is one of the GP models, genetic programming models, which could outperform deep learning with more than 800,000 nodes. So you can see how we can not only improve the accuracy, but also improve it with a very, very simple structure, which are also actually raise a philosophical questions that do we really need to always go to a very complex model such as deep learning or other machine learnings, or we can start from scratch and try to find and let other approaches such as evolution to build a structure for us. And actually this work also continued by Wilson et al. And based on that, MIT Technology Review wrote article and says neural networks have generated all the headlines, but a much more powerful approach is waiting in the wing. So if you're familiar with data analytics or and more specifically regression and classification, we need to do two main selections. One of them is selecting features, finding the optimum number of variables, and also finding the best variable and best combination of variables. And the other selection is finding the best model. What would be the best model for our case? For example, here you can see none of these models works, but one single model outperform all others and seems very fit for this problem. So we need to have to do some trial and error or some selections for features and models. But what genetic programming does is doing both of these selections inherently. It means genetic programming does feature selection and model selection via evolution. And another distinguished features of genetic programming is that it uses a population of solution instead of following one single solution or trajectory solution. It tries to build a population of solution, and so it has a low chance to trap in local minima. And also we can easily take advantage of now the era of parallel processing, cloud computing, and distributed systems. So I think most researchers right now in the field using parallel processing in genetic programming, unless they are dealing with very simple problems. So the first example I'd like to mention is one of the complex engineering problems. It's predicting a response of this complex structure. You can see it has some, it's a frame that has special elements such as this post-tensioning bar that connect the roof to the ground. It has some energy dissipation element between these two columns, and one of the columns can uplift from the base. And we want to predict the response of this structure, or more specifically, peak roof drift of this structure during earthquake. So this is the response of this structure during Manjil earthquake. So you can see, since earthquake is a stochastic phenomena, the response is also very stochastic. So we want to predict this point, the peak roof drift of this structure during a specific earthquake. So if you look at the variables for this problem, we have two different classes of variables. First, a structural design parameters such as geometrical and mechanical variables, and also earthquake intensity measures. I listed some of them here, but there are so many in the literature. So the prototype structure here is the office building designed for a soil site at LA, California. So this is the system that we are going to analyze, and 3 different elevation considered here: 4-story buildings, 6-story building, and 8-story buildings, and 75 different structure is designed as first, and then 170 earthquake applied to each of these design systems. So first, the difficulty that I had for this problem was how I can select the best intensity measures for the earthquake. So what I found is earthquake is a very nonlinear phenomenon, stochastic and nonlinear phenomenon. So one of the simplest way of looking at variable is looking at correlation coefficient, yes, but the correlation coefficient only find linear relationship between 2 sets of data. So what I did is simply improved correlation coefficient formula by genetic programming, actually incorporated genetic programming model into the system in order to find the nonlinear relationship between 2 sets of data. And actually, it worked very well. So you can see here, I listed correlation coefficient of some earthquake intensity measures with the target value. So this is the simple correlation coefficient value. And this is the one that I introduced for capturing nonlinear relationship. This is called evolutionary correlation coefficient. You can see how much improvement happened after applying, incorporating genetic programming into a correlation coefficient equation. So I have, for example, I listed the improved percentage of improvement here. In some cases, I have more than 200 or 300% improvement in correlation. So based on these new correlation coefficient, I selected the first 3 intensity measures for solving this problem. And one thing that I can explain quickly here is, after running genetic programming, we come up with a pool of solution. For example, I run it 50 times, and this is all the solution that I got. And I can put them all in a pool and then find the Pareto-Franz solution. These green dots are the Pareto-Franz solution. And after finding the Pareto-Franz solution, I can select one of them. For example, I usually select one from this area, since by moving from here to here, accuracy doesn't increase that much. but you can see the complexity increase a lot. So here, a model could be a good trade-off for complexity and also accuracy. So eventually I selected this model, and you can see this is the final equation for such a complex problem. You can see a half-line or one-line equation for this problem. So this is a multi-objective strategy as I described, and this is simply if we use single objective strategy. And you can see the accuracy is very high for this model. And the results recently published at IEEE TII, and you can refer to this paper for more information. Another problem that is very difficult to solve and doesn't have explicit solution in engineering community is inverse analysis. So models usually develop for forward analysis. For example, we have a system and we apply input and it gives us output. It calls forward analysis. But how about we have input and output, but doesn't have system parameters? It's called inverse analysis. So this is a complex problem. So in engineering problem, this is very common because we want the system usually change during time, sometimes damage, the parameters change during time. So we need to know the system parameters. So for example, for material modeling, there are several approaches are introduced for forward analysis, but there are only very few approaches for inverse analysis. One of them is the one proposed by Professor Qabusi. He and his colleagues proposed two parallel finite element analysis. One of them is displacement control, the other one is force control, and they try to update the stress strain database and then fitting a neural network model to this system, and they put this process in the loop until this system converged. But there is a problem here. So if, let's say, if we have an unknown material and use this framework, we eventually come up with a neural network, which is not only a complex system, but also a black box system, which means it's very difficult to take derivative from it, and it has its own challenges. But what I simply did is I replaced this neural network with genetic programming. So as I said, genetic programming can be easily translated to mathematical formula, and you already saw it in the previous case studies. So after translating it to the mathematical formula, we can now use this constitutive material model for different purposes, like developing Jacobian matrix, etc. So that's what we did in this study. So our case study was a space truss, cantilever beam space truss with 112 bars. This is the force displacement curve, and this is the result of Professor Ghabushi's framework. And this is the genetic programming that we developed, and this is the outcome of genetic programming. But what is handy here is now we have an explicit formula. Now we can simply use it in a software as a user-defined material. So that's what we did in order to test our genetic programming-based model. So it's the reference model, and you can see the distribution of stress into the system. And this is the genetic programming-based model, and you can see the distribution of this stress is almost identical in the genetic programming-based model. And we use this framework for soil modeling and also aortic modeling, and you can see it could predict with a high degree of accuracy. So I briefly told you genetic programming is a population-based algorithm. So some people came up with some approaches and says, why we threw all the population out and only select one single solution? We can use the all population or some portion of population in order to develop the model. So one way of using all population information is connecting those population using regression analysis. That's something that people already done. For example, Searson tried to connect different genes using regression, or the MIT Alpha Lab also combined regression analysis with genetic programming. So this is one of the studies that combining regression and genetic programming. So and we apply this approach for predicting the concrete creep. So this is a very complex problem which has happened during time, and you can see the equation is very simple. It has 3 genes. They are connected by linear regression analysis, and the result presented here, it's significantly outperformed the other approaches in the literature. So these are 3 other approaches, and this is the GP approach. You can see in terms of correlation coefficient and error, etc. It is a much better model proposed here. Several other studies we have done, I've listed some of them quickly here. For example, this predicting a student's performance when we put a headphone with a forehead scanner on each student. We analyze the signals, and based on that, we predict how much they learn those courses. For example, you can see GP here can predict it with 90% accuracy, while others cannot reach that much accuracy, even CNN, SVM, etc. And we also apply it for COVID. Let me move on. And there are also big data that we can apply genetic programming. So I can briefly explain this approach that we use in order to apply genetic programming for big data analytics. So here we have a difficulty. We have a difficulty of finding the structure, which is infinite search space. This is a very, very big search space if you want to find a structure. So what we did here is, instead of solving n-dimensional problems when we have n variables, instead of solving n-dimensional problems, we try to solve n one-dimensional problem, and then have an equation for modeling interactions. So the process described in this paper, and I won't go to the details, but here I visualize how it can improve the convergence and also accuracy. So this is the approach that we propose. It's called multi-stage genetic programming, and this is a regular genetic programming. You can see how quickly it can move forward. So I can pass the case studies and briefly go how evolutionary intelligence can be used for optimization. So if I want to briefly say, there are 2 classes: mathematical optimization and also nature-inspired or evolutionary intelligence optimization. So nature inspired, they usually called global optimization because they can deal with complex system and also different constraints. And they don't trap in a local minima very easily because they do not use derivative information. And they use other sources of information such as evolution, swarm intelligence, or annealing. And they have been already used for very complex problems. For example, in 90s, I listed 2 successful studies by Boeing for designing geometry, or by Merck in order to find the first clinically approved antiviral drug for HIV. And now so many companies are using it: Amazon, Google, Uber, etc. So we can use evolutionary optimization for very large scale problem. We can use it for multi-objective or many objective optimization problem, which actually the most problem in real world are multi-objective or many objective. We have to deal with cost, quality, time, risk, reliability, etc. For example, we applied evolutionary multi-objective optimization for developing policy for pandemic when we have 2 objectives: daily new cases as is stringency of planned intervention. And eventually our team actually was one of the honorable mention winner of this, the X Prize cognizant prestigious award, so which happened last year. I think there is no time in order to go into details, but I would like to briefly mention these evolutionary computation are very powerful algorithms, but they have one disadvantages. And that disadvantage is that they are slow in compared with mathematical optimization if you use them blindly. But if you import or embed your knowledge into the system, they could be much, much quicker than mathematical optimization. There are so many cases. I've listed some of them here, but I think we don't have time to go into detail. But as a last word, I would like to encourage you. So if you want to use evolutionary intelligence for optimization purposes, there are so many ways to accelerate your system. And it's better to not using those blindly, not going to, for example, Python toolboxes or MATLAB toolboxes and apply this system. You can simply improve and tailor those algorithms for your own problem, and they could be much, much faster. Okay, I think that time is up, so I can stop here and maybe take some questions from you.
Yes, we are all mesmerized by the words of Dr. Amir, and he enriched our knowledge on the topic of evolutionary data analytics and optimization, in which we learned about genetic programming, how genetic programming is useful for finding best evolutionary correlation coefficient, inverse analysis, and other things. So in audience, if you have any questions, we are ready to address it. You can write in the chat box.
Thank you so much, Professor Amir, for giving us some time to this conference and share your knowledge with the participants on this very the topic, the evolutionary computing is basically a topic which is very much in nowadays, and everybody is going to use this in their research. So, thank you, Dr. Amir.
Thank you for having me, and I'm happy to share some of these studies. So I know there is a limited time here. If anyone have, I can answer some question here. I would be happy to. Otherwise, please feel free to email me or ask me your question. And I would be so happy to also share our codes. You can find them online, but don't be shy to contact and ask for the codes.
Yeah. So thank you, sir. Now for the second keynote, I would like to invite Professor A.K. Singh, NIT Kurukshetra, India. He is qualified doctorate from Jadavpur University, Kolkata in 2004. Professor Avdesh Kumar Singh is presently working as a professor in Department of Computer Engineering at National Institute of Technology, Kurukshetra, with an all-over experience of more than 35 years in teaching and research. During this period, he has held the position of head of department, member, advisor, and convener, as well as chairman to various administrative committees at NIT Kurukshetra only. Based upon his professional and research domain expertise, he has been invited as an expert and resource person in various international and national level programs like session chairs in conferences, subject expert in short-term courses, seminars, and workshops. He has 50 plus research articles in reputed journals and international conferences, as well as book chapters to his contribution. His research interests include distributed computing systems, cloud computing, concurrent algorithms, and mobile computing. Please, sir, the stage is yours.
Good afternoon, and thank you very much for a nice introduction. I'll just share my slide. Hopefully, you can see it.
Yes, sir.
Thank you very much. So the title of my talk is Offloading in Edge Computing. So to begin with today's presentation, outline is computation offloading, the task models, criteria for decision on offloading, and some illustrative examples. First, before we enter into the topic, this slide shows an edge computing setup, how typically it looks like. I have taken reference from Genetics. It is an edge analytics platform. Here we can see that on the top layer that shows the cloud, then below that the core network, edge node, and the edge network. And in this setup, what we see that the information or data which is moving from the lowest point, that is endpoints, or you can say the edge points, and top to the cloud, and between them there are the different layers of the network. So in edge computing, the computation which is basically which is a kind of real-time processing which requires updating up very fast. In those cases, if we transmit information to the cloud and then download it, then lots of propagation delay, and the real-time applications do not respond in time, or you can say they did not respond with the deadline. And that is why the edge computing has come into the picture. Here, the information of data which is generated from the IoT devices like sensors and others, they are processed in the edge network or the edge nodes, and that is the basic setup. In this way, the latency for transmission, propagation, and processing, that is all reduced. So that is a typical edge analytics platform. Now, coming to the topic, means what are the prime concern in the edge computing? So first one is the latency. As I said, that because the information moves from the lowest point or endpoints to the cloud for processing, and that's why due to this latency, the real-time deadline that is violated quite often, and that's why we face the problem in running the application. So usually the range in the latency is 30 to 100 milliseconds, and in many latency critical applications, this is required maybe even less than 1 millisecond. So that is a prime concern, how to address this latency. Other deliverables, if you go for edge computing, that is mobile energy saving, because the IoT devices, they have the limited capability, especially the energy. They cannot be recharged. And that's why if we deploy them for performing some sophisticated tasks, so the most of energy is dissipated faster if we apply them for surveillance or crowd sensing, etc. And because the most of the IoT devices, they cannot be powered again, and that's why the challenge is how to save their energy. So offloading has come as a solution to this problem, and this will essentially, the usage of energy will be reduced, or you can say the minimized, and that's why prolonging the battery time. Second important thing is the deliverable in the edge computing is the context awareness. Means we can track because here the devices are in the proximity, and they are processed in the nearby nodes, which are edge nodes. So that's why we can maintain the footprints or fingerprints of the different motions or movement. So it is better to have, or we can have a optimal or better routing or navigation or the trip management. So that is another advantage of edge computing. And last one is the privacy enhancement, because in the edge computing, because we use the proximate edge servers, so because they do not have very concentrated information, because the information is distributed among the small scale. So due to less concentration, they are not susceptible to attack, because the attackers usually attack the centers which have the concentration of, or huge concentration of the information. So that is the another advantage. So the prime concern is the latency, but these two are the other deliverables like the energy saving, context awareness, and the privacy enhancement. Now, the computation offloading, as I said, that essentially the requirement, the objective is to save energy, or you can say the saving the energy of the IoT devices, speed up the process of computation. But the question is whether to offload or not, number one, and number two is that how much and what should be offloaded. So there are two mechanisms for offloading. It is binary offloading and the partial offloading, means either offloading the full data or maybe the part of that application. Some critical parameters which can help us in taking this decision. Those parameters are, as I said in the beginning, that latency, bandwidth utilization, context awareness, generality, and scalability. These are different parameters. On the basis of that, we can decide that whether a particular task or whether a particular computation or part of application that can be offloaded or not. And for this purpose, we need some sophisticated task models. It's not a simple task, so we need some sophisticated task models. So there are essentially, as I said, there are two types of the offloading. One is the binary offloading. So binary offloading means the full offloading. Means either it is offloaded or not offloaded. So here, the critical parameter for such decision is the input data size, number one. Number two is the deadline, that when the task is to be completed, accordingly it will be decided. And finally, the workload or the intensity that will be measured in the CPU cycles per minute. So on the basis of the value of these three critical parameters, it is decided that whether the task to be offloaded or it is not offloading. Now, use of these three parameters for taking an offloading decision is basically, the purpose is number one, to capture demand of the different users, and second one is the evaluation of the performance. Means by implementing this offloading or by going for this binary offloading, whether we have some performance enhancement or we are getting the better performance. That is one choice. Second choice is the partial offload. When I say partial, means because the different applications, different mobile apps, they are made up of, maybe sometimes constituted of multiple procedures, components. But essentially, it has the fine-grained design. So part of that application or part of that computation can be offloaded. So if we can partition it into one or two parts or more than two parts, then some part can be offloaded and some part may not be offloaded. So that is how the partial offloading is. So we create a data partition model, which can group the different procedures or the functionalities, and some of them could be offloaded to the cloud and some of them could not be offloaded to the cloud. But here, because the the binary offloading is very simple, and you can say it is easy to implement. But when we go for partial offloading, the different procedures or different components, different activities, they may have some dependency. Means the execution order, that cannot be arbitrary, because if we go for some arbitrary execution or arbitrary offloading, then it may affect the end result. So that is why the first point is the execution order, which dictates that which portion can be offloaded and up to what extent. And second is the due to hardware or the software constraint, or in other way we can say the resource constraint. So due to resource constraint, also the offloading decision that can be affected or that can be modified. Means some of the activities that will be done locally, and some of them, like say image display, so that has to be done on the mobile or the interface. So that is other thing. So these two things dictate. Now, what could be the task model for partial offloading to the cloud? So here we use the task call graph. That is it is basically a directed acyclic graph. So in that graph, the vertices represent the procedures and the edges represents the dependency among them. So and the edges, on the edges we put some weight. That weight is the representing the workload or the intensity of the computation. Resources required is workload, and resources required that can maybe the CPU cycles or the needed memory, etc. And what is the amount of data that each procedure can be characterized by the imposing some weights. So weights are essentially representing the intensity of computation or the requirement of the resources. Here, for our generic understanding of the dependency, there are essentially three dependency models: sequential dependency, partial dependency, and the third one is the general dependency. So in the sequential dependency, what we see here, that different nodes, as I said, that represent the procedures. So the tasks are executed in the sequence. Of course, there is no problem. But however, the parallel dependency means the sum of the tasks, they can be done in parallel, and some of the tasks, they may not be done in parallel. However, in general dependency, we have different, like say, for example, we can see that the execution of, maybe if I say that node number 5, that is dependent on the execution completion of node number 2 and 3. Similarly, others we can see from the picture. So these are the, in general, three types of the dependency that dictate the offloading decision. And in general, the first and last step means the first step is the basically input that we provide from the mobile device or our PDA. And the last step, that is the output that we see on our mobile phone or on our screen of the smartphone. So normally they are executed locally because it requires less energy. Computation that requires more energy. So that is the dependency models. Now, what could be the possible decision in the offloading? Means the number one is the execution could be done locally. When I say locally means, like if I say that in the red strip that represents, say, the user equipment, UE means the user equipment. So here, in the first case, the user equipment that offloads the entire computation, or you can say the entire application, to the cloud, or sorry, to the edge. So here, what we find that it is the total offloading. Means the local offloading, where we do the whole computation. Second one is the second case where we find that the full offloading, that is whole computation, is offloaded and processed as the edge computing. So one case is that whole computation is done locally, and second case the computation is done in the edge. Locally means the whatever is the user equipment, it can perform its computation, and here it is offloaded to the edge. And third one is that partially means the sum of the computation is executed locally in the IoT device or the local device, and rest or the major computation that is offloaded to the edge, that is the edge device. So the critical decision or the possible decision could be that to execute locally or to execute in the edge, or second thing is we can divide them, this some portion locally and some portion on in the edge. So although this task offloading that appears prima facie, it appears to be simple, but it is a very complex task because it is affected by the different factors like user preference, what user wants to do, radio and backhaul connection quality, user equipment capability, cloud capability, and other thing is whether we want to upload the fully or the partially. All these decisions are the complex decision, or it is not straightforward as it is. So the solution which is suggested here is the first solution which is suggested for such activity is that introduce edge intelligence. What is meant by edge intelligence? Means that introducing the AI in the edge. So nowadays the deep learning is the main representative of the AI technique, because there is a shift from the machine learning to deep learning. So we will not go in detail of the deep learning here because it is not in the agenda. But we introduce intelligence in the edge by using deep learning. So here the AI that or the deep learning concept can be integrated into the edge, means in the computing framework. And what is the aim is to deployment of the DL services or deep learning services by edge computing. So all the capabilities or the strength of the deep learning that can be exploited. That is one way that will help in taking the decision. Second thing is build intelligent edge. So there is a little seems to be overlap. Intelligent edge means now it is a dynamic and adaptive management of the edge. When we say dynamic and adaptive management means that it adapts according to the changing conditions or the different conditions. So these two are the important solutions, or they are helping in taking the decision. So introducing edge intelligence and intelligence. And above all means whatever we discuss about these in detail, because here it is not within the scope. These two are the mutually beneficial. Means if you have introduced intelligence in the edge, that will help in the dynamic and adaptive management. And secondly, if we have an intelligent edge, means the adaptive or the dynamic management which is available in the edge device, then of course we can implement intelligence in a better way in the edge device. So this edge DL or the introducing DL in the edge, that helps us in taking better decision about the offloading. So new form of the application which are coming up is the DL based intelligent. DL, what we see this deep learning based the intelligent services and the application. Because due to great advantage of the deep learning, advantage in many areas like computer vision, NLP, etc. So basically the purpose of introducing deep learning, that is because nowadays there is volume of data is very high which is to be processed, and the devices which are participating in the computation, they are also having the better computing power. Like even our smartphone now has the better or huge computing power. So it is easier to implement deep learning services into the edge. But the question is why it is not coming up in a big way. Means why we have limited introduction of deep learning based services. There are different reasons, like different parameters. Number one is the cost, because the introducing deep learning is the costly affair. Costly affair means the cost involved in the training, inference, etc. So that is one hurdle in the fast development or introduction of the deep learning services. Second is the latency that we have, because in time critical applications, because deep learning involves huge computation, because neural network, other things come into the picture. The deep learning is essentially execution is or using the deep neural network. So if we have huge computation, then of course the real-time applications or the time critical applications, they cannot guarantee or they cannot meet their deadline. So that is another challenge in introducing the deep learning into the edge. Reliability is another important issue because mostly the IoT devices, they interact through wireless communication, and we know it is a susceptible medium, and usually the connections are lost. So that is another challenge. Fourth and the most important is the privacy, because deep learning services are, if you incorporate the deep learning, so means if that the data required for deep learning is taking decision, that may involve private information. Private information means the different privacy issues that come into the picture. Like if you are introducing deep learning service in the smart home or the smart cities, so lots of private information is to be shared in order to take a more accurate or more feasible or popular decision. So that is why, because of these four parameters, the cost, latency, reliability, and the privacy, the deep learning is not coming up in a big way. Not being introduced in the edge, but by the passage of time, things are coming. Now, the question is, what is the criteria for taking a decision? Decision means whether the information or the app or the particular functionality, it is to be offloaded to the edge or it is processed locally. Because processing locally means we are executing in the IoT, and offloading means we are executing in the edge. So if processing locally means we are dissipating the energy of IoT devices, and which is difficult to recharge. And if we are uploading to the edge, then we are introducing the latency, because from the IoT device, the data is transferred or transported to the edge device, and after computation, it will be downloaded or it will be sent back to the IoT device. So this propagation latency is introduced. So we need to see the offloadability of a particular application. That is a criteria for design. Whether it is offloadable. When I say offloadable means a particular app or the computation, whether we can partition it, and after partitioning, maybe some parts they can be processed locally and some parts they can be processed locally means in the IoT device, and some parts can be processed in the edge device, or that can be offloaded to the edge. As we see in this diagram, that the portion or the part of the task 1, 2, 3, 6, and 9 that is processed locally in the IoT device, and the 4, 5, 7, 8, 10 that is offloaded to the remote, even the edge device. So that is one thing, means offloadability. That is one important parameter in taking this. Second thing is that if we partition a particular app or some data, then there could be some portion which cannot be offloaded. Like we see here in this diagram, that some part which is shown in red, that cannot be offloaded. Cannot be offloaded due to multiple reasons. So some part cannot be offloaded. Like for example, say user input. So that cannot be offloaded because it has to be done locally. Camera or acquire position of all these data that cannot be offloaded. It is to be done locally. So some part is offloadable part and some part is that cannot be offloaded. So non-offloadable and offloadable. So offloadable part that can be offloaded and some part cannot be offloaded. Now question is how to utilize and manage offloading process. Offloading to the edge device. So here there are three major components, which are number one is the code profiler that will determine what could be offloaded. System profiler that determines that monitoring the various parameters, and decision engine that takes the final decision that whether to offload or not. So that is another thing, means the having the components whether they are offloadable or not. That is the another criteria. Now, second criteria is the knowledge on amount of data, because for taking an offloading decision, we need some data or some information. And how much information we have, because for taking a better decision, naturally, if we have more data or more information, then of course we can take a better decision in the offloading. So amount of data known beforehand means before we take a decision. And second thing is, in the some cases, it is not possible to estimate, because like I said, continuous execution, like if you are playing a game. So it is very difficult to decide that which part, because you do not have much information in the advance, and that is why it is difficult to take a decision. So here taking a decision in the continuous running execution or continuous execution is very tricky. Means that cannot be very accurate or it will require more amount of data. Third important criteria is dependency. Dependency partially we have discussed previously in the few slides. But here means a part of app can be independent or it could be mutually dependent, because that relationship, as I said earlier, that dependency graph that can be used for the dependency. For example, you can see this graph. Here the red edges, red vertices, they represent that the part of the app or you can say the application or the data that cannot be offloaded. Like we have given the example that camera input that cannot be offloaded. So like 1, 4, and 6, these nodes cannot be offloaded. And the other which are shown in green or light green, that is offloadable part. So what we see that from this component dependency graph or this curl graph, we can decide that when to offload. Like for example, here we see that second and third, which is of course the offloadable part, that can be offloaded after the execution of node 1 is over. Means whatever task is assigned here or whatever is the part of computation is at node 1. Once it is completed, then 2 and 3 can be offloaded. Similarly, if the 2 and 3 part can be offloaded here, that we have seen after first part. Similarly, we can see that fifth part that can be offloaded if this portion means node 1, 4, 2, 3, all are the computation is over. So this dependency of difference offloadable part that dictates that when to take a decision of offloading, number 1, and how much portion can be offloaded. So that's how these are the different criteria for taking decision. So as I have shown in some previous slide, that there are 2 offloading methods. Number 1 is the full offloading. What is the objective of full offloading, or you can say the binary offloading? First one is the minimize delay. Delay means the latency, execution delay. Second thing is the minimize the energy consumption. Because even if we try to offload some portion of the task or some portion of computation or app or data, then this offloading means it has to be sent to edge device, and this job is of the IoT device, and IoT devices are the thin devices. They have the poor battery backup or they have low battery backup. So that's why minimizing energy consumption is another very, very important objective of offloading. Because if you make full offloading means you are minimizing the energy uses of IoT devices, because the entire task is offloaded to the edge device. And third is because sometimes it is not possible to take a binary decision, or sometimes it is not even beneficial to take a binary decision. Then we make a trade-off, means how much portion of a task can be uploaded and how much portion can be done locally. Now let us see an example, means how we compromise, how we make a trade-off between the different latency as well as the energy consumption, because these two are sometimes orthogonal. Because if you want to save energy, then we are introducing the other type of the latency, and if you want to reduce the latency, then we are dissipating more energy, because IoT devices are less. So here there are two types of things. First one, if we call the latency, for example, if I say D, or latency means the delay. Of course, these two are the synonyms. So delay and latency, what could be the different type of the delay? That is the number one is the execution delay. Execution delay. So here execution delay means the DL means the local execution. And second one is if we are offloading, then there are three types of the latency come into the picture. Transmission, because we transmit to the edge. Then we perform processing in the edge. And then finally, we spend some energy and time in downloading or sending back to the IoT device. So these are the two concerns, means the latency, means that is delay, and the energy. Now let us see an example that how these two are we can make a trade-off. Here we see that there are two user equipments, UE1 and UE2. if we see this bar graph, we find that DL represent the local, means the latency in local execution, and DO is the latency in offloading. So what we see that DL is less than DO. It means if it is the case for user equipment 1 or UE1, we find that DL is less than DO. So that's why it will take a decision to execute locally. In other case, because it will take a decision to offload, because we find that DO is less than DL, means if it offloads, then latency is less. So that's why it will take an offloading. That is one example. Other example is that instead of taking some binary decision, we can have a computation policy or computation offloading policy that is on the basis of channel state information and other execution information. So we take a decision, means whatever tasks are pending for execution in the buffer, we may decide that which task is to be executed locally and which task it will be transmitted or the sent to the edge device for execution and production. So in this way, it will be able to create a better balance if we use an algorithm. Let us see the trade-off between the energy and the latency. Like if we see in this diagram here, that the pie graph left side, what we see that energy consumption in local execution is less as compared to energy consumption is in offloading. So naturally, if we consider the energy, then the user equipment 1 will take a decision to execute locally. It will save the energy. In other case, the user equipment number 2, it finds that offloading takes less energy. So that's why it will go for offloading. So UE1 will be taking that because to reduce the energy. However, in other case, if we take a decision, like for example, the delay here, delay in local execution is more than delay in offloading, but there is a maximum delay. It is both are below that. So what we observe that if we consider only latency, means the delay in, so delay here in the offloading delay is less. So that's why it will go for this, but it will spend more energy in execution because energy consumption is more. Similarly, here also what we find that delay is less in local execution, but the energy consumption is more. So that is why taking a decision whether the execution should be done locally or it should be offloaded to the edge, that is a trade-off between the latency as well as the execution, as well as the the latency as well as the energy consumption. So these are the critical decisions, and they are not so straightforward. Now, if we take some decision, means offloading decision. So because what we see from the previous diagram, because if we take a trade-off between the energy and the latency, so essentially it is an optimization problem because you are trying to minimize some parameter or maximize some parameter. So it is basically an optimization problem. So you know that constraint Markov decision that is usually used for this optimization problem. In general, there are two different types of the strategies used for the allocation. One is the online learning. Online learning means the network adapts dynamically because you take a decision, but dynamically you are changing the decision. And second one is the pre-calculated offline strategy. So either you take a decision on the basis of changing conditions of the network or the different dissipation of the energy or the available battery backup, etc., or you take an offline decision or pre-calculated. So in general, not it is in general that because what is the prior information we can pre-calculate, that is basically the arrival rate, channel condition, all these are different things that may be sometimes known in advance. So it has been proven by the different researchers that offline strategy performs better. The reason is very simple, because we have more amount of data available for taking decision. Because we have more information, so of course we can have a better decision. But this is true only in the case of low and medium arrival rates, where the offline strategy performs better. But if it is a very fast arrival rate, then of course you cannot capture lots of information. So then other performs better. But if it is a dynamic decision, then the dynamic could be based on, maybe it's a deterministic offline strategy, or it could be a randomized strategy. So all these different mechanisms that come into the picture. It is not only the offloading decision. Basically, if we take a decision, then accordingly we should be able to allocate the resources also. Resources means the execution resources. Means once we take a decision that the computation is to be offloaded or not, accordingly we need to allocate the resources. Means there has to be a proper allocation of resources. Like we find that, and for proper allocation, because of the offloading decision, all these things that is based on whether some functions can be executed parallelly, whether we can partition it and parallelize it. On the basis of that, we can take a decision that whether to offload, not to offload, dynamic offload, or you can say the static offload decision. However, if parallelization is not supported, or maybe sometimes partitioning is not supported, then we can take decision accordingly. Like you find here in this diagram, UE1, user equipment number 1, that is offloads whole application to edge device. You can say, see by this dotted line. However, the user equipment 2, partially it is executing locally, and some part it is sending to the edge device or the edge computing. So the offloading decision depends on the partitioning and parallelization support, and accordingly the resources are to be allocated. Here, like say, there are two example apps given. For example, we take a face recognition app, for example. So here the different components which are used in the face recognition app, essentially the 5 components: image acquisition, face detection, pre-processing, feature extraction, and the classification. These are the different activities. So what we find that image acquisition means the acquiring, that is executed on the mobile, because the user interface is on the mobile or the smartphone. So that is executed locally. Other components which involve huge computation, like face detection or pre-processing, feature extraction, all these, that require huge computation capability. This will drain the entire energy of the IoT device. So that's why these are performed, these are sent to the edge for execution. So this dotted rectangle that shows the components which are being executed at edge server or edge node, and this image acquisition is local. So that is one example. Second example is a augmented reality AR app. So in augmented reality, there are major 5 components, because there is a video source, then different activities. There is a renderer, tracker, mapper, object recognizer. All these are the different components. Rather, you can say these are 5 critical components. They are involved in the augmented reality applications. So we find that the sum of the components, like we see that video source and renderer. What is the renderer? Means which is processed, means the frame by frame for display. So basically input and output, you can say that. So these are executed locally because it's a kind of interface with the user. And other 3 means the tracker, because which tracks the position of the user, mapper, which is builds the environment, and the object recognizer. These involve huge computation. They will drain out the energy of IoT device. So that's why these are being sent or being executed in the edge device, and these 2 are executed in the local device, or you can say that. So these are the 2 examples of these edge computing apps. So By this, I come to close of my talk, because what the organizers have told me, the deadline is 4 o'clock. So thank you very much for giving me time. Now I am open to if audience have some queries.
Yes, thank you, sir, for your precious knowledge. Sir enlightened us about the edge computing, its latency, deliverables, task offloading, computation offloading, and other valuable knowledge. And if anyone have any questions, they can write in the chat box, please, and they will be addressed. I believe there is no question.
Okay. Thank you very much. Thank you all for giving me opportunity to share my views. Thank you very much. Hopefully, I have been in time.
Yes, sir. So for the final keynote of the day, I would like to invite Dr. Vipul Kumar Mishra, Bennett University, Greater Noida. Dr. Mishra is working as Associate Professor at Bennett University. He is a postdoctoral scholar at the University of Kentucky, USA. He had completed a PhD degree in Computer Science and Engineering from Indian Institute of Technology, Indore. He has completed multiple sponsored projects from various agencies such as Bharat Electronics Limited, National Skill Development Center, and Radio Mirchi. He had published 46 research articles in various reputed journals and top-notch conferences. He is an NVIDIA DLI ambassador for computer vision. He has conducted more than 30 workshops on artificial intelligence and deep learning across India. He has also given expert talk in various FDPs on deep learning for resource-constrained device, natural language processing with deep learning, and deep learning for computer vision. His current research interest is focused on deep learning for computer vision and NLP, embedded AI, tiny AI, edge AI, atomic AI solution for disaster management, ICT in agriculture, swarm optimization, nature-inspired optimization. And the topic of his keynote is deep learning model compression and acceleration for resource-constrained devices. Please, sir, the stage is yours.
Thank you, Satyam, and thank you, organizer, to invite me for this particular talk. So first of all, if you hear some bird sound or something, so excuse me, because right now I'm in my hometown and suddenly I got this information. So please excuse me if you have some bird sound or some other sounds here and there. Okay, on the top of it, the beauty, like I was listening the previous talk from Dr. Odis, and it looks like I'm going to continuation of his talk. So whatever problem he showed in their talk, like there is a latency problem, there is a space problem. So I'll try to solve those problems with my talk. So might be that will complete the entire process cycle. So let me quickly share my slides and move forward. So please confirm if you got.
Yes, sir. Visible now.
Is it in the full screen mode?
Yes.
Great. So thank you. So let me move forward. So today we'll talk about how we can train a model. We already know how to train a model, but the most important part that we will focusing on, if you already have a trained model, that is specifically deep learning model, so how you'll put into the edge. That was the previous agenda of previous talk. How we'll put into the edge, because DL is powerful. We already know that DL is very powerful. So how exactly we will modify our model so that we can put our deep learning models into the resource constrained devices or these edge devices or these IoT devices. So let's move forward. So first of all, let's understand the evolution of computer. I start from very beginning because that will give you a theme why it's important today. So might be like our senior professors aware, whenever we are working in our BTech or MTech in the labs, there was terminals where we have one single server, all the powers in the single server, and we are harnessing their power from the terminal. Now, same thing happening today itself in case of AI. Right? We have a cloud computing server that is in somewhere in the cloud, and these IoT devices are trying to connect and get the power of AI from there, or you can say power of deep learning from there. So it means we are again coming back into the similar kind of situation where we have one single source of server, or you can say AI engine that is serving multiple terminals. So again, we are going into the era like moving forward, and we are giving power of this AI into the terminals, or you can say right now we can say these are the edge devices. So some similarity right now we can feel in terms of AI picture, right? So we have one very big cloud where all these edge devices try to harnessing the power of AI, or you can say power of deep learning for various vision related tasks or NLP related tasks, right? So how to solve this problem? So let's move forward and think on first of what are different edge devices that we are talking about. These edge devices, or you can say resource constrained devices, can be your mobile phone, can be the drone, right? Can be the robots, can be the self-driving car, right? Can be the glasses, or maybe any new IoT device as well, where we require the power of deep learning into the edge. Instead of transmitting our data from the edge to the server, we want to take decision in the server itself. Well, that is the today's need. So what is the problem in front of us? So the bigger problem, huge network. Right. If we talk about like a network that is evolved in 2012, that is the LXNet, that itself have 60 millions of parameters. It's a huge number of parameters. Like now, if you look into the in terms of flops, or you can say floating point operations, so you can say we have lots of floating point operations as well that involve into the computation itself. So one side is the number of parameters that we need to store somewhere in terms of that is the memory problem. And another side, we require CPUs or GPUs to operate those floating point operations, to perform those floating point operations, to take a simple decision, right? So these are big challenges with the deep neural network. If you look into the mobile phone, it's not only the operating over there. Most of these resource constrained devices are battery operated devices. So we have to look into the energy side as well. We have to look into the latency side as well. Is really mobile phone have sufficient energy to operate those operations, to work on those operations, while it is required lots of energy to perform multiplication, to perform addition, to perform just transfer in the memory in between memory itself, right? So these are energy side as well. That is also creating a much bigger impact whenever we talk about resource constrained device, right? Now, just only the resource constrained device is really that is the only reason why we want to minimize those operations or compress those models. Let's look into the latency side as well. There are plenty of applications where we required real-time operations, or you can say real-time analysis, where FPS makes a bigger impact. How fast you can do the operation. Now, whenever we talk about fast, whenever we talk about speed up, then what comes into the picture? Number of operations. Can we reduce those number of operations so that we can do much faster speed? Let's take example. Suppose right now we have 100 millions of operations in our neural network or in our deep neural network. Suppose somehow we are able to reduce number of operations by 80%. Now we have only 20 millions operations instead of 100 million operations. We have 20 million operations, and we are getting almost similar performance in terms of accuracy, right? Then definitely we look forward for those kind of network that is giving similar performance, but lesser than 20% of parameters, lesser than 20% of operation. So directly you can say your network speed up is boosted by some percentage, right? So these are top-notch reasons why we need to compress our models. Now, these are two choices that we have. First choice, can we put our model into the cloud? Definitely, it's very easy to put our model into the cloud. But what will be the problem? There can be a network delay. There can be power consumption. Now here, what power consumption I'm talking about is the communication power. Definitely, whenever you want to transfer huge amount of data, let's say you are trying to process something on the video. So you have to transfer the entire video into the cloud. Then only it will analyze that video and perform the operation. So in that case, that is the transferring the data into the network. Then user privacy, one of the biggest challenge, the user privacy is really all the users want to share the data. Most of the time it comes into the picture, no, I don't want to share the data. That's why they are not using the deep learning or they are not using the AI systems just because of they don't want to share the data. So if we give a solution that will perform in the edge device itself. So what will be the challenges in the edge device? Suppose we look into that side as well. So the first major problem is the RAM. Do we have sufficient memory to store those big models? If you look into the mobile phone, yes, definitely we have. But if you look into the tiny IoT devices, then they do not have sufficient memory itself. Running time, or you can say latencies, that is also a very big problem. That also Dr. Odesh talk about. Latency is one of the biggest challenge. We are looking for a very high latency in multiple applications. So we can't go jump into the edge devices. Similarly, power uses. Now here, when we talk about the power, that is when we run these models, how much power it is consuming, how much energy it is consuming. And sometimes if you are really in the rural area, then downloading and storing is also a bigger challenge because there we do not have sufficient speed. So let's look into these problems in the both sides and try to come up with a solution. So bigger questions, or the important question, can these 8 devices take decisions? The same questions that the same question that Dr. Odesh is also talking about. Can these edge devices take decisions? So the answer is yes. So one way, make these devices powerful. Already some hardware companies are doing that job. So in terms of hardware engineer, they are doing that job. They are making your mobile phone, your IoT devices powerful. But what is our job as AI engineer? Can we make these decision process itself computationally lesser expensive? Or can we make these processes small itself so that this process can run on a resource constrained device? So let's look into the our part. I'm not jumping into the hardware part, how to make these devices powerful, but we are looking for the AI part. Can we reduce the computation requirement of these DL models? Right? So what will be the advantage and disadvantage? Suppose somehow with a trick or with a particular procedure, we are able to compress these models. So what can be the advantage? What can be the disadvantage? So the advantage side, you require lesser space to store. You require lesser energy to compute that have low latency, means higher speed. That will be lesser computationally expensive. But other side, definitely if you are getting so much, then you have to pay something back. That is, maybe accuracy will reduce. I am saying maybe because there are something related to that. Why it is maybe? It's not compulsory you are reducing the accuracy, but maybe you are reducing the accuracy. So let's jump into that. So what are various methods to do that? First and very popular method is the pruning. So I'll give you a lot of time in the pruning. How exactly pruning happen? What are different processes in the pruning? Then there is another method that is quantization. And you know, like this quantization we already done in many processes that we are doing in our computer science. So let's do this in the deep learning models itself. Then similarly, there are various architecture itself that are reducing the computation requirement. Right? Similarly, global average pooling, or you can say depth-wise separable convolution, and many more. So we'll talk about that as well. So let's jump into the first important method, that is the pruning. Right? So how we'll make these models small? Right? So let's come to the human brain itself, because we all know like deep learning models are inspired from the human brain. And how human brains are performing that operation, because our human brain itself is doing the pruning. So whenever a kid is like 2 years of old, we know the kid is most naughty. The naughtiness actually coming from his brain or her brain, because their synapses that is in their brain that is most dense in that 2 years of age. Now, slowly, as they move forward, they go to the school, they do very specific job, then automatically the synapse that is not responsible for those that are dormant, who are not doing anything, they are rid of. The human brain itself start the pruning. So you can say, as we move to the higher age, our brain have lesser synapse. Right? So that's the way how human brains are doing. So why in the age of 2 years it's more synapses are there? Because we are looking in the entire world in like different aspects. Right? So same thing happening into the deep learning models as well. So someone say like, how it is useful? So let's look into the weight distribution after training. That gives you a sense, weight distribution after training. So you can look at that the weights of the parameters that is close to like 250,000 parameters have weights of 0, or you can say close to 280,000 weights are 0. And we all know, like when you perform a convolution operations, these weights are multiplied by the value. And we all also aware, if you multiply by 0 with a value, there is no impact of that particular value. It means we have similarly, if your value is 0.0001, and if you multiply with a number, that is also negligible. So with this graph, we can easily figure out there are lots of parameters which are either 0 or very close to 0. So what we can do? We can straightforward rid of those parameters. That is not important for us. That is not important for making a decision. So that is the task of pruning. So let's understand how exactly we can do the pruning. So there are various ways to do the pruning. One is like a fine pruning, then coarse pruning, static and dynamic. So we'll jump into one or more variety of pruning. So what exactly pruning is? So one way to look into the pruning is like weight pruning. So what exactly happening? Suppose we have this model that is like a neural network. Now what we found, like few weights that is not important for us. When you say how we can figure out it is not important for us, that is one big research question itself. But for simplicity, we can say we decide a threshold. If the value of that particular weight is less than threshold, then you can say it's not very important for our process. Or you can say which is very close to 0, that is not important for our process. So what we can do, we can read off that particular value. We can remove that particular weight itself from the network. So we have very a network that is not dense in the nature. Right? Lots of nodes can be prone, lots of edges can be prone. Right? So there are two ways to do that. One way, you are making those weights equal to the 0. But as we all know, like if you just make that age equal to the 0, it means your matrix that is storing these particular weights is not reducing down. They will remain same. But in terms of cost, in terms of computation cost, or you can say operation, that is the MAC operation, that will reduce down. Because system is aware if you are multiplying a number with a 0, you do not need to multiply. Answer is 0 itself. So actually they will not perform the multiplication operation. They will directly put into the 0. And system is also aware, like if you are adding something into the 0, then that will remain same. Right? So in that way, your process, or you can say your operations are reducing much more. Right? So, but what we'll get? We will get a matrix that is sparse in the nature. This matrix can be a kernel matrix. This matrix can be a 2x2 matrix in case of fully connected layer. In case of convolution layer, this matrix can be a kernel matrix that is sparse in the nature. And we all know, like whenever we have a matrix that is sparse in the nature, then we require a dedicated hardware for that. Oh, this is again another problem. One side we are saying it is reducing the cost, but another side I'm saying it will require a dedicated hardware to get actual power of that pruned network. Right. So how to solve this problem? But before jumping into that, there is a one big question. How much we have to prune from individual layers? That's a very big question. How much you have to prune from fully connected layer, how much you can prune from first convolution layer, second convolution layer, and so on. For that, we can do a sensitivity analysis. What the sensitivity analysis is saying, suppose we keep all other values remain same and we are playing with one single network, one single layer. So for example, in case of convolution 1, we try to prune the layer and we see accuracy is reducing as we prune more than 25%. It means the convolution 1 layer is very sensitive to the accuracy. If you are trying to prune little bit, they will impact in the accuracy. So the big question, why it happened? What was the reason behind that? So the reason behind that, why this convolution 1 network is very sensitive to the accuracy, because they are extracting very basic features that is required for developing highly complex feature, right? But in further layer, we are using those basic features. But if we do not have sufficient basic features itself, it means we are dropping lots of information that we required further. Now let's jump into the fully connected layer. Even if you remove close to 75% of the parameter from fully connected layer, they will not impact a lot into the accuracy, just some 0.1% drop in the accuracy. It means there are 75% of parameters which are either close to zero or redundant in the nature. They are not actually impacting the accuracy, or you can say they are not actually creating any important information into the network. So we can read off that parameters. That is coming from the sensitivity analysis. Similarly, if you look into the when magnitude-based pruning is doing, we are able to prune this much parameters, that is the green one, and we remain with only the blue parameters. And we are getting almost similar accuracy. Almost similar accuracy. That's the beauty. Means initially we have 60 millions of parameters and we have only few millions of parameters, hardly like 5 or 10 millions of parameters, and still we are getting similar accuracy. And that is the power of pruning. Right. So now let's understand. We got an idea, like if we remove randomly with the threshold based, then we require a dedicated hardware. Why? Because that is creating a sparse matrix where we have most of the values are 0. So then we come up with another idea. Instead of removing individual weights, we are removing a complete node itself. Because once you remove a complete node, that is removing all the parameters that is related to these nodes. All the parameters. It means your matrix will not be sparse in the nature, but it reduced. The size itself is reduced. Right? So you do not need any specific hardware, same hardware, or you can say similar way, you will do the operation. You can say instead of 4 nodes in the middle layer, we have only 3 nodes in the middle layer. 1 node is not important for us. So just rid of this node, or you can say remove this node. So now you can say how to do that. So the simple way is using the regularizer. We already know when we are using regularizer to remove the overfitting. What regularization is doing, they are trying to reduce the value of weights so that it will not overfit. Right? So we simply try to use the similar concept and increase the value of lambda so that regularizer will be more stronger. Now it intentionally reduces the weights. Now once you remove or reduce the weights, then you have lots of weights that is close to 0. Right? Now when you have lots of weights that is close to 0, so we find out we're putting a threshold where all the neurons that is less than threshold, make it 0, right? For the input and for the output. So you can say input side and output side. And you can find out a node where all the nodes of their input and the output are 0. As you increase the threshold, then automatically you will get multiple number of nodes where inputs and outputs both are zeros, right? And remove those connections. Now you can say you will remove the complete connection. Instead of removing some weights from a node, you are removing the node itself. And that's the beauty behind this node pruning, right? Or you can say instead of weight pruning, right? So you can see here, suppose this is your previous layer, this is the next layer, and if you remove a node, so what will happen? The entire column in the previous layer matrix will be removed, and entire row from the next layer matrix will be removed. It means you are able to reduce the network itself, reduce the number of node itself, instead of removing some particular weights. Right. Now, what are different methods? So that is one way to solve the problem or reducing the size of neural networks. Then another way is the quantization. So what exactly we are doing in the quantization? In case of binary quantization, we are trying to make these weights, which are bigger in the number, 1 and -1. Simply, if they are greater than 0, then make it 1. If they are less than 0, make it 0. Right. So in that way, what exactly we are trying to do? We are trying to reduce the size by 32x, right? But what we are getting a speed of 7x higher, right? So the speed will be much higher as compared to the size, right? So now the beauty here. Beauty is we are focusing on the speed. But the biggest challenge, we are reducing the accuracy by 20%. So this is like a first step towards the quantization. Then they say, no, it's not actually fruitful because you are reducing 20% in top 5. So what additional we can do, right? So then they come up, instead of making it binary, let's make it 8-bit uniform binary. So we already know, like as in the binary system, if you increase the number of bits, then definitely you have much more accuracy in the particular weights, right? You have 8-bit information now. Instead of one single bit information, you have 8-bit information, right? So now it will become much faster, size will drop by 4%, and it is acceptable in many classification tasks. That's the beauty. Now still we find out like there are some particular portion where weights are more dense in the nature. So suppose you have a graph, so the graph is like this, then this, right? So these are two portions where you have higher weights. So how to come up with a method? Instead of uniform, they are saying non-uniform method. So you look into this particular graph, what this graph is saying, these are the weight values, right? So in a particular portion, if you have very high weight values, then you will give more bits to these portions and give very lesser bits where we have no values. So the dense, where we have the dense values, you are giving much more number of bits into this particular portion. That's pretty interesting. Like you are giving more weightage where we have more weights. But the question is how to do that? What exactly way so that you can able to do it? So the way is weight sharing mechanism. So let me give you an idea of how exactly it will be done. So what we are doing, here we have some color coding. So there are something important in the color coding. Actually, it's not simply color coding, it's a clustering. You are doing clustering of the weights. So you can say where we have this yellow color, it's close to 0, 0.09, 0.14, 0.05, 00. It means if we take this cluster, this weight of cluster, and give you one cluster value, right? Then these weights will go to the first cluster, let's say. Similarly, in case of second cluster, you are saying, let's look into the higher values. So it's a 2.09, 2.12, 1.92, 1.72. They are higher values, so you are putting into one cluster. Now you can say the cluster centroid is representing the entire cluster. And in that way, you are not losing the values, but you are getting only most important information in this cluster itself. So what we are doing, we are creating a centroid. For example, for the higher values, you have created one centroid. For the lower values, you have created one centroid, and so on. So now, if you look into this, you have 4 different clusters in this particular part. So let's look into the size side, right? Suppose initially you have all the values in 32 bits. So you have 16 value in 32 bits. Now we have 4 values, only 4 values in 32 bits, and their representation, that is the cluster index, that required only 2-bit information because you have only 4 values, 0, 1, 2, and 3. It means this will represent 2-bit information and this will represent 32-bit information. So simply we are able to reduce the size drastically, but we are able to maintain the values. So for example, in case of inference, suppose you are looking for the value here in this particular matrix. So it is coming from cluster 1, you directly go to the cluster 1, okay, its centroid is 0, and you will pick that value. And that is actually, if you see, these are close to 0, so it will not impact a lot. So that is the way how you do the weight sharing in times of, at the time of training itself. And that is the way you are able to compress the network very heavily, and you are getting almost similar accuracy as well. So this is the way how this particular network is doing. Now, what they try to do, they are trying, instead of taking one single value, they are taking multiple such methods and combining together. So first they do the pruning. Once you have pruned model, then they apply the quantization. Now we have you can say a model that is, so once you do the pruning, that is 10% of the size is remain. Only 10% of the size you can think of. Now once you do the quantization, you have only 3.7% of the original size. So 100% is reduced. So you can say 100 numbers is reduced to 3.7. And we are getting almost same accuracy. It means if you have a model that you are think of to deploy into the edge, you are able to easily deploy into the edge, because now its size is 3.7%. Along with that, their computation is also reduced by 90%. So if it is reduced by 90%, it means you are able to reduce the energy consumption also close to 90%. That's the beauty behind this compression. Right? Then there are various architectures as well. That how much time I have left with, so that based on that I will forward.
Sir, you can take 5 more minutes, I think.
Okay, great. So there are some architectural modification itself. So what is architectural modification? One way, you already have pre-trained model and you apply the compression schema, either pruning or quantization. Then another way, can we think of a model architecture itself that is small in the nature, right? And also preserve the accuracy. So lots of researchers work in that direction. Can we make our model small enough itself? So the one way to handle it, one way is the fire layer. So just I'll give you brief input of this particular convolution operation is 28 cross 28 cross 192. And what we are expecting after performing 5 cross 5 convolution, and same means the size will remain same, 28 cross 28, and how many filters we have? 32 filters. So output will be 28 cross 28, 32. Now if we look into the number of calculations and number of parameters to perform this one single convolution operation, it is close to 120 million calculation. When we talk about calculation, it means only the multiplication. I'm not jumping into the addition, just multiplication here. Even if you add the addition, that will be much bigger, right? But because multiplication is highly computationally expensive, so we are taking the multiplication into the picture. right? So here 120 million multiplications happens. Similarly, in case of parameters, we have close to 1,53,000 parameters, right? In just one single convolution operation. Now we introduce the fire layer. What is fire layer? It is 1 cross 1 convolution. So the summary here is saying, even we are getting similar output with introducing one additional fire layer, what it is producing, it required only 12.4 million calculation, which is 10, it's like 10x smaller than previous. Similarly, in case of parameters, we required only 15,000 parameters to perform this operation. And the beauty here, if you look into this output and this output, these are almost similar. What pattern we are looking for? The similar pattern they are giving as an output. So that's the beauty behind this fire layer. Similarly, we have global average pooling. So previously we are using the fully connected layer. So they say fully connected layer is very computationally expensive block. Just rid of this fully connected layer and come up with the global average pooling. So we do not have any fully connected layer in the Google Net. That is the architectural modification to reduce the computation. Now, one last method that is very interesting, and it's like reducing a network in manifold, that is student-teacher network. So now what exactly, how exactly it's happened? Suppose we have very complex tasks, right? That we want to make it a smaller network. So what we'll do, first thing, we create a teacher network. That is a very big network, right? And that is doing the operation. Now, once we have a teacher who is like taking n number of, so in similar teacher student that we know, teacher is reading, like for creating 1 hour lecture, teacher is doing their homework approximate 6 hours or 10 hours to just delivering 1 single hour of the lecture. So what the teacher is doing, they are taking lots of information and then give you most precise information at the end, right? So same thing, you are creating a very big network and you are looking forward into these values. These are the final values that is looking forward to produce these final outputs. So what shallow network is doing, or student network, first we create a data set, simple data set. What will be the data set? Input image will be this and output will be these values itself. These are known as the qubits, that these values, right? Now these values is the output for our network, right? Now let's look into the student network. What we are trying to make, we will make a 2-layer network, simple 2-layer network that is producing this output and while getting this simple input. What this output will be, it will be the similar output that this layer is producing. It means this entire part we are rid of with one single network. That is the way how you are producing student-teacher network. This is also known as knowledge distillation process, right? So this is the way how you can make a smaller network from a very big network. So these are various methods that you can apply to make either during the training or post-training to make your network very small. Then there is like a very famous method, that is the neural architecture search, right? That is also doing the similar work. They have multiple network, creating multiple networks and find out the best network for you. Similarly, we have autokeras as well. So ultimately, what we figure out, if you want to deploy your model into the edge device, you cannot go as it is. You have to process that model and compress it so that it will take lesser energy. It has much higher speed and it consumes lesser space to store as well, so that you can deploy into the edge device and your edge devices will become intelligent itself instead of sending the data to other places. So that was the overall theme of this particular talk. So thank you very much. If you have any queries, please let me know.
Yes, thank you, sir. Sir, it is the problem of deep learning in resource constraint like mobile, self-driving cars, etc. and issues on edge devices. The synapse part was quite reinventing. A small kid is naughty. Thank you, sir, for this informative session and keynote. And now over to Shreya.
We have had an extremely useful day. We have learned a great deal and are very much in depth to all the speakers. As we all know, only 70 out of 370 submissions have been selected for Scopus proceeding plus publication. But at the end, I would like to add, in addition to final selected 70 papers, other papers have also added a lot to conference in terms of new direction of research. Maybe they are not up to the mark this time, but I hope if continuous effort is to be applied in this direction, that these research will also make history one day. We will continue to do effort to bring researchers and academicians together to develop new possibilities for advancement of India and entire mankind. So stay connected with us for future announcement of conference. Thank you everyone. We are grateful to all who have accepted to be the part of this conference. Thank you for making this a huge success.